Hello everyone, welcome back. In this video, we are going to implement combat mechanics into our AI. But before we do that, we need to cover the basic design of our combat AI. Okay, this is going to be our basic design. And so every behavior tree starts with the root, and from the root we have our main selector. The main selector will run a service that updates the behavior of the AI. When one of the children nodes succeeds, the selector will succeed, and start checking again from left to right. So it's going to check the conditions of each of these, and the check that I'm going to have for each of these will be a behavior type enum. The correct behavior node will run depending on the behavior type enum. The behavior type enum is updated in the behavior service, and the behavior service will be added to the main selector. The behavior service will constantly run so that it can track what the AI is doing and what the AI should do next. Okay, so now that we've gone over that, let's go into the engine and get started with the implementation. Okay, so the first thing that we're going to need to do is create a new enum. Okay, so let's go to Combat System Blueprints AI and let's create a new folder. We'll call this one enums. So this is for AI enums, blueprints, enumeration, and this one will be e_AI behavior. Okay, open it up. And here we can add the different kinds of behavior that we want our AI to have. So the first one will be nothing. Okay, let's add a few more. This one will be attack. This one will be chase. This one will be patrol. And this one will be hit. And that'll be enough for now. So now let's go to our behavior tree. Go ahead and open it up. Let's go to our Blackboard. Let's add a new key. And this will be of type enum. We'll call this one AI behavior. Go ahead and expand key type. And we need to select AI behavior here. And now let's go back to the behavior tree. And let's add a new service. We'll add that to behavior tree nodes. Okay, and we'll call this one S_ for service, and we'll call it update behavior. Okay, let's add a event receive tick AI. Okay, and this service will run as long as the node that it's added to is running. So what we can do in here is we can go ahead and create a new function. We can call this function update behavior. Okay, and we're going to need some information from the AI. So in order to get that information, we need to set it. So we need to add a event receive start search AI. And this is where we're going to update our information. So we get the control pawn and let's cast to master AI. And we'll call this one controlled master AI. Okay, let's go ahead and promote the owner controller to a variable, and we'll simply call it owner controller. Okay, now let's go to update behavior. And we're going to need the controlled master AI and the owner controller. So let's check, is this valid? And is this valid? And we should only continue if this is valid and if this is valid. Okay, now let's get the controlled master AI and let's get the state manager component. And from here, let's get the current state. And let's check, is the current state equal to dead? If the current state is equal to dead, then we need to set the behavior to something. So now we need to create a function to set the behavior. So create a new function and let's call it set behavior. And let's create a new variable. And this variable will be of type Blackboard key selector. And we'll call this one behavior key. Okay, let's make that instance editable. Let's create another new variable. This one will also be of type Blackboard key selector. This one will be target key. Let's make that instance editable. Now let's get our behavior key. Let's set Blackboard value as enum. Okay, and let's create an enum here. And the enum will be AI behavior. We'll call it new behavior. And we'll just go ahead and plug this into the value here for set Blackboard value as enum. Okay, compile and save. Let's go back to the update behavior function. And if this is true, then we set behavior to, let's actually do this as a not equal enum dead. So if it is not equal to dead, then we can continue. Otherwise, we set behavior to nothing. Okay, now let's get our target key and get blackboard value as actor. Then we'll check is valid. If the target actor is valid, then that means the AI can see the player. Otherwise, it means the AI cannot see the player. So if the AI cannot see the player, then we want to set behavior to patrol. But if the AI can see the player, then we can continue. Let's go ahead and create a new variable. This will be of type Boolean. And this one will be B can see player. Or we could say can see enemy. And that will be the enemy to this AI. Yes. Okay, and now we need to know if the AI should attack the player or if the AI should chase the player. And to do that, we have to know the distance. So to do that, let's actually go ahead and promote this to a variable first. This L underscore target actor. Okay, and now let's get the target actor. Let's get distance 2. And the other actor will be the controlled master AI. Okay, and now let's promote this to a local variable, and this will be the L underscore distance. Now, let's get the distance, and let's check, is it less than or equal to a certain value? And this value, we can actually promote that to a variable, and we'll call it attacking range. And we can make that instance editable, so that we can adjust it from within the service. By default, I'm going to make that something like 500. Okay, and if that is true, let's add a branch. And let's set behavior to attack. And if that is false, let's set behavior to chase. And that should be enough for now. Okay, so the only thing we need to do now is we need to run update behavior on event receive tick AI. Okay, now let's go modify our behavior tree, and we can rename this one to main selector. And let's add our service to the main selector. We'll run the update behavior service. So one thing that we're going to have to do is let's create a new task, go to behavior tree nodes, and we'll call this one T underscore perform action. Okay, now let's event receive execute AI. And what we can do here is let's create an interface. I don't believe we have an interface that will perform actions, do we? Let's check. Interfaces, I don't see any. But we can make this in Combat BPI. So that'll be fine. Let's create a new function and we'll call it perform action. So perform action name is already taken, so we can call it perform combat action. Okay. And this will be a gameplay tag. We need to add another gameplay tag. The first one will be action tag. The second will be state tag. And then let's create an integer. This will be the montage index. And let's create another variable. This will be a top boolean. And this will be random index. Since this is a boolean, this will actually need to be b random index. Okay, now let's add a return value. And this will be and this will be a float, and this will be action duration. Compile and save. Now let's add another one. Perform combat attack. And basically what this function is going to do is find perform attack. We'll pretty much run this function or something very similar to this function. So the inputs that we will need are going to be similar to this one. So we're going to need attack type, attack index, and random index. Let's add those inputs. Gameplay tag. This one will be attack index, so integer, and then a boolean. Call this one attack type, attack index, be random index. Okay, let's add an output. This will be a type float. This will be attack duration. Okay, compile and save. Now let's go back to the master AI and let's go ahead and copy all of this. Let's actually cut it all. And let's delete perform attack. Yes, I want to delete it. And let's go to the interface, perform combat attack. Let's paste all of that in here. Okay. And we can plug the attack type in here and create a local variable for this one and get attack index. Okay, now I need to get random index. And we need to get attack index again. Set here. And we need to return 0 here. Okay, we need to get attack type here. And we need to create a local variable for attack montage. Okay, now we need to promote the montage duration to a variable, promote to local variable, and we'll call it local underscore attack duration. Okay, and here we need to return the attack duration. So we have some errors here. Charge attack, we actually probably don't even need this for an AI. And all this stuff about continue attack. We may need some of this. We actually probably don't need this for an AI either, but just in case, we can just call perform combat attack, and we can just plug these in here, which I do not think we're going to need this for AI, but we may need it for something, but I doubt it. If we don't need it, we can come back and delete it. For now, we can just leave it. Okay, everything else looks pretty good. This toggle combat, we do not need this either. Okay. Let's actually add a category for this. It's kind of annoying for there not to be a category for it. Since all the functions are just out here, it would be nice to add a category to this. We'll call it combat actions. We'll add this one to the same category. Okay. Okay, so now let's go back to our perform action task, and from the control pawn, we'll call perform combat action. Okay. And now what we need to do is let's promote this to a variable, and this, and this, and random index. And let's make all of these visible. Now let's promote this to a variable, and we'll call this action duration modifier. So this will basically allow us to modify the action duration. And the action duration will be, and for the action duration, we'll need a delay. And then we can add a value onto it. And the value that we are going to add is going to be the action duration modifier. So that means we also need to set this to since editable. Okay, now plug that in here. And then after that, we'll run finish execute. And that will be a success. Okay, that should be good. Okay, and so the first node that we are going to add, let's add a sequence. Let's add a decorator, a Blackboard decorator. We are going to check, this one will be on result change, and the aborts will be self, and the Blackboard key will be AI behavior. We're going to check, is the AI behavior equal to nothing? If it is equal to nothing, then we wait. Okay, and the next one will be, let's do patrol next. So let me go ahead and move this over here. And so we can actually add a comment, nothing, a comment to this one, patrol. Okay, now let's change the Blackboard base condition. The Blackboard key will be AI behavior, and we need to make sure that the AI behavior is equal to patrol. Okay, and now let's add attacking. And we can actually also rename these nodes. Call this one nothing. We'll call this one patrol. And this one will be attacking. Now let's add a decorator, Blackboard decorator. Okay, and so we need to check, is the AI behavior equal to attack? If it is, the first thing we need to do is set movement speed to 400. Okay, and after that, let's add move to. We need to move to the target actor. Let's go ahead and add a decorator, a Blackboard decorator to this, and we'll use this to make sure that the AI behavior is equal to attack. The observer reports for this one will be self, so the AI will stop moving to the player if the AI behavior enum is not equal to attack. And now we need to perform an action, but for that we need to create a new task, and now we need to perform attack task. So for that we can go to behavior tree nodes, let's select perform action, and we can duplicate it by pressing Ctrl+D. We'll call it perform attack. Okay, open it up, and from control upon, let's perform attack. Let's just replace all of these nodes. Okay. Now we can delete state tag, and we can rename action tag to attack type tag, and montage index can be renamed to attack index. Compile and save. And now let's go back to the behavior tree, and let's run the perform attack node. And the attack type tag will be action attack. Let's add a new attack type, and this one will be close range. So that added the close range. The attack index can be, let's do random index. That should be good for now. Okay, let's add a comment. Attacking. Okay, and this one will be chase. In order to chase, we need to check, is the AI behavior equal to chase? There we go. Go ahead and test this out. In order to do that, we need to AI. Let's open up our humanoid enemy. Let's give him a weapon. So we need to give him a static mesh. We need to drag the static mesh over to the character mesh. This will attach the static mesh to the character mesh, and we need to call this weapon mesh. And now for this weapon mesh, let's set the collision to no collision. Now let's add the tough sword. Okay, and by default, we will attach it to the right weapon socket. It's not exactly attaching to the right weapon, so we can make this 0 and this 0. There we go. Now we can also implement toggle combat functionality for the AI, but we will do that here in a second. We just want to get it working for now. And now the next thing that we can do is let's add the collision component. We'll call this one main weapon collision component. And this will be weapon start, and the in-socket name will be weapon. And then we need to add an on hit event. And we can do something similar here to what we did in the base weapon. So let's go ahead and just copy all of this. And actually, let's delete that. And let's go to the master AI. Let's add the collision component to the master AI. Main weapon collision component. Okay, now compile and save. Okay, and start socket name will be weapon start. End socket name will be weapon end. Okay, go back to the humanoid enemy, recompile. Let's see. Main weapon collision component. Okay, let's add the hit. Okay, in this one we just do nothing. And for the damage, let's just promote that to a variable. We'll just call it base damage. Or actually, instead of doing that, we can just get the stats component and get it as a stat. Get current stat value. Do we have damage? No. So let's add that as a stat. Enums, stats, add enumeration, damage. And so now let's go back to the humanoid enemy. And actually we can close out a lot of these that we're not using anymore. Save all. Now in the humanoid enemy, we can get we need to recompile, and then we can get the damage stat. Plug that in here. In the damage type class, I do want to add that to the master AI. So let's just copy that, go to master AI. Then we can throw it to variable, damage type class. We'll put this in a category damage. Let's get off of that, and let's make the default value attack damage type. Okay, go back to the humanoid enemy, and then we will select the attack damage type. Okay, plug that in here, and plug this in here. Okay, and now let's add some attack animations to our humanoid enemy. Let's see here, do we add that already? So yes, it looks like we have. Let's just get light attack 1. Let's get light attack 2 and light attack 3. There we go. Okay. Now let's see what happens. So it seems as if we are having some problems. I think I know what the issue is. We did not update the values in our service. So the behavior key should be the AI behavior. The target key should be target. Okay. Okay, let's try something different. Okay, so let's go here and let's add an event. Event receive activation. Here, let's set behavior to patrol. So that way the AI can start off patrolling. Let's see if that works. It looks like the AI isn't patrolling. So we've made some sort of mistake. Let's go take a look at our behavior tree and see what we've done. Let's just delete this Blackboard-based condition and let's add it again. Observer aborts will be self. This will be AI behavior is equal to patrol. Okay, now that should fix the issue. Whenever we spawn in, the character should be patrolling. Okay, there we go. And let's make the AI see us. Okay. We are having a bunch of glitches with our camera, but it is working. Okay, this video has gone on quite long, so I think I'm going to end the video here. We will continue setting up our enemy combat AI in the next video.